point-slope form of a line. The point-slope form of a line is y minus y sub 1 equals m times x minus x sub 1. That's the equation of a line passing through the point x1, y1 with slope m. So in this lesson, we will practice graphing lines that are in this form, and we will practice writing the equations of graphed lines in point-slope form. Here's our first example. Graph and write the equation of a line in point-slope form that passes through 3, 5 and has the slope of 4. So the slope of 4, rise over run, I'll go down 4 into the left one. I like to use as much of the graph as possible so that when I connect my points with my straight edge, it's accurate. So here is the line. I've graphed this line. Now I want to write its equation in point-slope form, which is y minus y1 equals m times x minus x1. That given point, that solution of 3, 5 is x1, y1, and the slope is 4. So we'll just substitute in the values. And our equation is y minus 5 equals 4 times x minus 3. That is the equation of the graphed line. Let's try another example. Here we're told to write the equation of a line passing through the given point of 2, 3 with the slope of 0. Now this is interesting because the slope of 0 will yield a horizontal line. That's a special case line. So the equation of a horizontal line is y equals 3. It goes through the y-axis at 3. Every point that lies on that line has a y-coordinate of 3. Okay, let's try another one. Here we have 2 points, and we're asked to write the equation of a line passing through these 2 points. First, let's plot them. -1, 3, and then 4, 5. Now we'll connect them with a straight edge. And the rise over the run is going to be up 2 and to the right 5, so 2/5 is the slope. All right, we have 2 points. We can choose either one in our formula, and we have a slope. So we'll choose the first point, the -1, 3 as x1, y1. Let's substitute in place of the formula. So it's y minus 3 equals 2/5 times x minus -1. We are going to just simplify that by writing y minus 3 equals 2/5 times x plus 1. And we have completed the task. We've graphed the line. We've written its equation in point-slope form. All right, so now we'll go the other direction. We'll give you the equation of the line in point-slope form, and we're asking you to graph the line, identify a solution or a point that this line goes through, and its slope. All right, so good idea is underneath the line that's given to write the point-slope form of a line. Now let's see if we can revise the given equation so it's in point-slope format. So we're going to rewrite it as y minus -3 equals -2 times x minus 2. Now you can see the solution, right? The x1, y1 is 2, -3, and the slope is -2. Now that I have the point that it goes through, I can graph that point. I know the slope is -2, so let's go down 2 into the right one, or up 2 into the left one, and we can graph the line. Okay, so another example, write an equation in point-slope form of the line graphed below. So here is the graph of the line. Let's identify the point that we want to use, 2, -2. Now use rise over run to get the slope. The slope is 3. And I have everything I need to write the equation of this line in point-slope form. So my x1 is 2, My y1 is negative 2. So let's write down y plus 2 equals 3 times the quantity x minus 2. That is the equation of this line that's shown. And just to kind of take it one step further to make sure that that line makes sense, I can write it in slope-intercept form by distributing the 3 and then subtracting 2 from both sides. We can see that this line will go through negative 8 and the slope is 3, so that makes sense. All right. Write an equation in point-slope form of this line. Well, it's the same line, but what if I chose the other point, the 3, 1? It's the exact same process, but I'm just using a different solution. But just to prove that this would be the same line, I'm writing this also in slope-intercept form, and that kind of hopefully shows you it doesn't matter which point you choose as x1, y1.